Thank you all of you for joining today's session. In our discussion, we are going to talk about the determination of heat of solution. The name of today's experiment is to determine the heat of solution. It is similar to the enthalpy calculation. We have done the enthalpy calculation for chemical reaction by using bond energy or bond enthalpy in our theoretical part, HM 117. Here we are going to calculate the enthalpy of a solution. That means when we dissolve any solute in a solvent, what is the change in the in terms of heat, in terms of thermal energy of the system. That will be calculated in this experiment. We have already learned that when we want to break the bond, it requires the energy, which is endothermic process. When the bond is formed, it is releasing the energy, which is exothermic process. So each of the processes, either it is chemical change or it is physical change, related to some extent of thermal energy releasing or thermal energy absorption, which is exothermic or endothermic combination. In the chemical reaction, we have found that for the reactant, we need to break down all the bonds, which requires the energy, and that amount of energy is related to the activation energy. And after the formation of bond, a certain amount of energy is released, which is the form due to the formation of bond. So here, the exothermic and endothermic happening simultaneously for each of the chemical reactions. Here we are going to use not the bond enthalpy or bond energy. We will use a calorimetric method. This method is called calorimetric method because here we are going to use a calorimetry to sense, to observe the change in the solution, especially from the in terms of thermal energy, enthalpy change of the solution. Here, as you know that in a solution, there is two parts. One is solvent, another one is solute. Solvent is the large phase and solute is the small phase. Now, when we are dissolving some solute in the solvent, what exactly happened? Let's see. I would like to change our demonstration. Here, I've called it the thermochemistry because this chemical process related to the in terms of thermal energy. We're going to calculate the enthalpy of a solution, and there are some terminologies which are important: solvation and hydration. Solvation means when we dissolve any solute in a solvent, and when the solvent molecules are making some physical bonds with the component or with the elements or ions present in the solvent is called the solvation. And hydration is similar to solvation, but in this case we usually use water as a solvent. So when water is used as a solvent, and water molecules are surrounding all the ions or the elements or the components present in the solution as solute, then that is called hydration. But if other solvents are used, then that is called solvation. So solvation is commonly called, and hydration specially called for water. Solution is a homogeneous mixture of two or more substances. The solute is are the substance that present in smaller amount. Solvent is the substance present in large amount. And an electrolyte, you have found this word in ionic compounds. When some ionic compounds are dissolved in any solvent, they converted themselves into ions and carrying the electrical charge. That's why they are electrolyte. Non-electrolyte, usually the covalent bonded substances, because they do not conduct electrical current in the solution because of their ion, because they cannot produce any ion. Solute and solvent, that could be different. Solute could be gas, liquid, solid. Even solvent could be solid, liquid, and gas. So no matter which phase in the substances, any kind of phase can be a part of solution. Now the question, there are some terminologies related to the solution: saturated solution, unsaturated solution, and supersaturated solution. Saturated solution means the amount of solute and the amount of solvent. There could be some ratio. If the ability of the solvent is the ability to dissolve a certain amount of solute, and when the exact amount solute is dissolved in a solvent, that means the highest amount of solute is dissolved in the solvent, then that is called the saturated solution. Contains the maximum amount of a solute that will dissolve in a given solvent at specific temperature. And unsaturated, when the less amount of solute is present. And supersaturated solution means when more than the maximum, we have called the saturated. That means after the saturation, if we add some more solute, then that is called supersaturated solution. Actually, during the solvation or during the hydration, which are happening, because all these are the intermolecular force of attraction, and we have discussed just shortly in our chemical bonding and physical bonding. In chemical bonding, these are the primary type of bonding which are present in chemical substances or chemical elements in a compound. And other types of intermolecular force of attraction or physical bonding, these are present inside, among or between the molecules in a system. So this type of bonding are like ion and dipole interaction, hydrogen bond, dipole interaction, ion induced dipole interaction, dipole induced dipole interaction, and dispersion. Later on, in our theoretical part, we will talk about the physical bonding, but here, especially the ion dipole interaction will be existing in our solution process. That means when the solvation will be done, during the solvation, ion dipole, because we are going to dissolve the ionic compound in water. So ionic compound will be separated into its ion, and depending on the positive ion and negative ion, the water molecules will surround them like this here. What you can happen to see here, I would like to show you in more elaborately later. Here, which type of interactions are present in a solution process? First of all, when we are using the solvent, that means the solvent and solvent will interact each other. That means solvent molecules. If it is water, so water molecules will make some bonds between themselves, which we call the physical bonding or secondary bonding. Solute-solute interaction. If we dissolve sodium chloride, sodium and chlorine, the chloride ion, how do they make the compound? Due to the electrostatic force of attraction. And solvent-solute interaction. So first of all, solvent-solvent will be connected to each other. Solute molecules will be connected to each other. And later on, the solvent and solute interaction will be happening. You can see here, we have taken some solvent, and when we are stirring, then the solvent molecules are a little bit separated from each other. We have taken a solute, and you can see there after the when we stirring, the solute molecules are broken down into their components. And during the solvation or during the making of solution, you can see here inside the intermolecular space, the solute molecules are hiding themselves in the solvent. So this is actually the solution. In large version, solvent little bit separated, solute they're separated, now they're combined together. That means the solute molecules are hiding themselves inside the intermolecular space of the solvent. So this is solution. Now what's happening during the hydration, you can see here. If it is a sodium chloride, if we dissolve, then sodium and chlorine chloride ion, they have separated into sodium ion and chloride ion. Now you can see there in the water molecule. In the water molecule, oxygen is more electronegative. That means it has a value of 3.5. On the other hand, hydrogen has 2.1. So you can find out the difference between oxygen electronegativity and hydrogen electronegativity. So it could be 1.4. So what will happen? This oxygen will drag the electron more strongly towards itself. As a result, oxygen will be del negative and hydrogen portion that will be del positive. So when the sodium ion will be available in the water molecules, the water molecule, the oxygen part will surround the sodium ion. You can see there as there are, and also in water molecule there are two lone pair of electrons. These are the lone pair of electrons, so they are not shared by anyone. So this portion is totally negatively intensity. The charge intensity is higher here. So this is del negative. You can see here the del negative. So del negative is surrounding the positive sodium ion around the sodium. So this is the solvation for sodium ion. Similarly, for chloride ion, you can see as it is a negative charge. So the water molecule, for water molecule hydrogen, if this is del negative, so this should be del positive. So this positive side is attracting or making some physical bonding, or this is called secondary bonding, which is ion and dipole interaction. Water molecules are dipole or polar solvent. So they are making some physical bonding. It's called ion dipole interaction or intermolecular force of attraction. So this is the solvation for chloride ion, and this is for solvation for the sodium ion. In our experiment, please listen to me carefully. In our experiment, we would like to use sodium hydroxide and potassium nitrate. So we can guess for sodium hydroxide, when we are dissolving sodium hydroxide, this portion will be same, but only this will be changed by hydroxyl ion. And hydroxyl ion is negatively charged, so similar thing will be happen. Only in case of chloride, it would be hydroxide. So this is for sodium hydroxide. If we take sodium and for two solid will dissolve. One is sodium hydroxide, another one is potassium nitrate. Now when we will dissolve potassium nitrate, in case of sodium, it will be potassium ion, and in case of chloride, it will be nitrate, but the thing will be same. So the solvation for sodium chloride, solvation for sodium hydroxide, solvation for potassium nitrate, all will be in the similar pattern. But when we will carry out the experiment, we will find that for sodium hydroxide, when we are dissolving the sodium hydroxide, the initial temperature of the system and the final temperature of the system, there would be different. Usually for sodium hydroxide, the final temperature will goes up. That means if we start our solution process at 25 degrees Celsius, maybe after the completion of the solution, the temperature, final temperature will be like 40 degrees Celsius. So you can see here the 15 degree has been increased. On the other hand, when we are dissolving potassium nitrate in water, if we start at 25 degrees Celsius, and after the completion of a solution, it will be like 15 degrees Celsius. That means you can see that the system temperature has goes down. So for the first one, when the system temperature is going up, that means it is exothermic process. It is releasing the energy to the surrounding from the system. On the other hand, in the case of potassium nitrate, we are going to get some decreased temperature. That means it is absorbing the temperature from the surrounding, which is an example of endothermic process. So exothermic and endothermic will be found. Later on, we will calculate how much heat or how much thermal energy were absorbed during the potassium nitrate dissolution, or how much energy would be released during the sodium hydroxide solvation. Later on, we will calculate the enthalpy. Earlier, you calculated the enthalpy for reaction del H. Here, we will calculate del H for solvation process. But the process would be different. The calculation process would be different. Earlier, we used lattice energy or bond enthalpy, bond energy. But here, we will use the mass of the solution, the temperature difference, initial temperature and final temperature difference, and the specific heat of the solvent. So let's see what is what we are going to do in this experiment.
In this video, we'll look at solvation. The IUPAC says that solvation is an interaction of a solute with a solvent which leads to a stabilization of the solute species in the solution. The way to think about this is that if we have a solute, let's say sodium chloride, and we put it into water, before the sodium chloride can actually be dissolved into a homogeneous solution, there needs to be an interaction between the water molecules and the ions in the sodium chloride. Similar thing occurs with sugar when we dissolve sugar in tea. The sugar is going to need to interact with the water to become solvated or stabilized in solution to make a homogeneous solution. One of the phrases you'll often hear with solvation is like dissolves like. Let's take a look at this idea. Let's look at these three possible substances. First one, sodium chloride. With sodium chloride, we need to think about what type of interactions this compound has. We know that the sodium likes to give away electrons and the chloride will accept, so this is going to be an ionic compound. If we look at water, H2O, here we know that we have a strong dipole moment. We also have a hydrogen attached to an oxygen, so this is going to be a hydrogen bonding compound. We can also say that it is very polar because it has a dipole, molecular dipole moment in one direction. If we look at hexane, here we just have carbon and hydrogen covalent bonds. We know that because of the electronegativity difference between carbon and hydrogen, these bonds are not polar. So therefore this molecule does not have any bond dipoles, and therefore the molecule does not have a molecular dipole. What type of intermolecular forces would hexane have? Well, without ions, hydrogen bonding, or dipoles, what is left is London dispersion forces. If we tried to dissolve sodium chloride in hexane, there would be a substantial difference between the molecular interactions of the ionic compound and the London dispersion interactions with the solvent hexane. These are not like enough to dissolve, so therefore they do not follow the like dissolves like, and we'd imagine that if we put salt into hexane, that it would just sit at the bottom of the hexane as a precipitate. If we think about sodium chloride into water, well, we already know this one. This is salt in water. This is going to dissolve. These are similar enough, like enough, so that it dissolves. So what is the process? Well, what's actually happening with the sodium chloride is that the water is interacting with the two ions. We can think about this as the water is actually breaking the sodium chloride into its ionic character. So if we look at the sodium would interact with the partial negative of the oxygen, and the oxygen would stabilize through the interaction of an induced dipole with the ion to give us a stabilized sodium ion. A similar thing happens with the chloride, but on this side it's going to be the partial positives that are on the hydrogens that will stabilize the chloride ion. This is the stabilization that's referred to in the definition of solvation. Here we can see the solvation of sodium chloride in water. Now in this case it's ionic, so it breaks into its ions. That's not always the case. If it is not an ionic compound, it's a covalent compound, but we still have the same type of stabilization interaction. This interaction is an intermolecular forces in solution. Most of the intermolecular forces you might have learned at this point are between pure compounds, dipole-dipole, London dispersion, hydrogen bonding. When we have a mixture, we have a few additional intermolecular forces. Those are the ion dipole, which would be the case of the sodium ion in water, dipole-induced dipole like CO2 in water, so carbonation, and ion-induced dipole. An example of this is the iron ion reacting with oxygen and hemoglobin. These interactions are important to whether a molecule will dissolve into the solvent. The other thing we want to think about with solvation is the enthalpy of saltation. The enthalpy of the solution is going to be equal to three enthalpy terms. The first one is the separation of the solute molecules. There's an intermolecular interaction between the solute molecules, and we have to break this interaction before we can start to create a solution. This is going to be an endothermic reaction. The second enthalpic term is going to be the separation of solvent molecules. Again, there is an intermolecular interaction between the solvent molecules, and we have to overcome this energy. This is also an endothermic reaction. The last process is going to be the interaction of solute and solvent molecules to form the solution. This will be an exothermic process. So if we look at it, we have two endothermic processes, delta H1 and delta H2, the separation of solute and separation of solvent molecules. And then we have the interaction, or the coming together, of the solute and solvent molecules to form new intermolecular forces so that we have an exothermic process. So therefore we can think about the enthalpy of solution as one of these three possible cases. If delta H3, solute and solvent interactions, is less than that of the enthalpy for the solute and the solvent, then that'll be endothermic. If delta H3 is equal to delta H1 plus delta H2, then that will be in an equilibrium. And then if delta H3 is greater than delta H1 plus delta H2, then that'll be exothermic. Often cold packs or hot packs is actually just a solvation process, either an endothermic solvation process in the case of a cold pack, or an exothermic solvation process in the case of a heat pack. Solvation is pretty straightforward. Like dissolve like will be an important concept to remember. The scientific basis for like dissolves like is the intermolecular reactions. So whenever you see a substance, think about its intermolecular interaction. Is it ionic-ionic, hydrogen bonding, dipole-dipole, or London dispersion forces? This will help you understand whether something should be soluble or not soluble in the solvent. Practice and become confident.
Hello viewers, I am MD Shoykat Ahmed. I am working as a chemistry lab assistant at IUBAT, International University of Business, Agriculture and Technology, Dhaka, Bangladesh. Today we will do an experiment. The name of the experiment is Determination of Heat of Solution and Enthalpy of Solution. Dear viewers, when you will dissolve salt in water, you will see that temperature will be changed of the solution. Temperature may increase or may decrease. If the system release heat, then it is called exothermic process. If the system absorb heat, then it is called endothermic process. So in this experiment, we will learn about two processes. One is exothermic process, another one is endothermic process. To calculate heat of solution and enthalpy of solution, we have to follow two equations. One equation for heat of solution calculation, another equation for enthalpy calculation. Equation for heat of solution is Q equal to Cp into M into delta T, where Q equal to heat of solution, Cp equal to specific heat capacity of water, and its value is constant. It is 4.18 joule per gram per degree Celsius. M equal to mass of solution, and delta T equal to final temperature minus initial temperature. Equation for enthalpy calculation. Del is equal to minus Q by N, where Q is the heat of solution and N equal to mole of solute. You can calculate N equal to mass of solute divided by molecular weight of solute. Now I will show you the apparatus that we are going to use in this experiment. First one is the calorimeter. It contains a thermometer also. Measuring cylinder. We need a spatula. We need wash glass. Wash bottle. for measuring the weight of salt, we also need a electronic balance. Now, I will show you the procedure that how can we do the experiment. Today, we will do the exothermic process. For exothermic process, I have to take 50 ml water. I have measured 50 ml water by measuring cylinder. Now, I will take this 50 ml water in the calorimeter. So I have taken 50 ml water in the calorimeter. After taking this 50 ml water in the calorimeter, I have to take the initial temperature reading. So our initial temperature is 30 degrees Celsius. So our initial temperature is 30 degrees Celsius. Now I will take 5 grams of sodium hydroxide in the calorimeter. Already I have taken 50 ml water in the calorimeter. If I will add 5 grams of sodium hydroxide on that water, so what will be the mass of that solution? Mass of that solution will be 50 plus 5. It will be 55. So the value of M will be 55. Now I am adding 5 grams of sodium hydroxide in the calorimeter. Now I will extract the solution by the extractor. Now I am seeing that temperature is increasing continuously. Our initial was 30 degrees Celsius. Now temperature is almost 45. That means temperature is increasing. Now it is 50 degrees Celsius and it is not increasing. Now we have to wait for a few moments that we have to see the temperature will increase or decrease. Now temperature is 50 degrees Celsius and temperature is not increasing. Temperature is stable at 50 degrees Celsius. It means our maximum temperature is 50 degrees Celsius. So our final temperature will be 50 degrees Celsius. So value of delta T is final temperature minus initial temperature. So we have got final temperature 50 and initial 30. That means delta T equal to 50 minus 30. It will be 20 degrees Celsius. Now put the value on the equation and calculate heat of solution. After calculation, we have got heat of solution 4.598 kilojoule. Now you have to calculate enthalpy. For enthalpy, we know the equation del is equal to minus Q by N. Q already we know 4.598 kilojoule. Now we have to calculate N. N equal to mass of solute divided by molecular weight of solute. We know we have taken 5 grams of sodium hydroxide. That means mass of solute will be 5 and molecular weight of sodium hydroxide is 40. That means molecular weight of solute will be 40. So N equal to 5 divided by 40 equal to 0.125 mole. Now put the value on the equation and calculate enthalpy. After calculation, we have got enthalpy is minus 36.78 kilojoule per mole. Dear viewers, we have done the exothermic process. If you do the endothermic process, you have to take potassium nitrate salt. When you will take the potassium nitrate salt, your temperature will be decreased from the initial temperature and you will get the just opposite result of exothermic process. In the exothermic process, you have got del S is negative, but in the endothermic process you will get del S is positive. Thank you everyone for observing this experiment.